Okay, next we will discuss isothermal process. Now, as per definition, the isothermal process may be defined as, let us write down the definition. It is defined as the process in which change in pressure and volume occurs at constant temperature. So what does it mean? That during this process the temperature remains constant. So delta T is equal to 0 throughout the process. So let us try to understand the process in a piston cylinder arrangement. And assume there is a gas which is kept inside the piston and the cylinder. Now this is the gas. Now this piston is free to move. Now let us assume we have put a weight which is in very small strips, in the form of small strips, and the initial coordinates, let us say, has P1, V1 and T1. Now let us assume I remove a very small weight dW. I remove this weight. So what will happen when I remove the very, you can say, fraction of weight from this piston? There will be a very, you can say, slightly change in pressure acting on the gas. So this piston, in order to this, you can say, equalize the process, this piston will move in backward direction and in upward direction. So it will go into the new position just to take the system in equilibrium conditions. Piston will move slightly upward directions. Now this is the new coordinates. Pressure becomes P2, volume becomes V2 and temperature becomes T2. Now you must keep in mind that during isothermal process the walls of the system should be very conductive, because when I remove the weight there should not be any increase in the temperature. So in order to keep the temperature constant, when I remove the weight, the pressure is you can say reduced, and the temperature of the gas may be reduced by some amount. So in order to compensate for the temperature, that heat may come inside the system so that the temperature remains constant. So for this the walls should be very conductive. So you can write here conductive walls allow heat transfer. So this is apart from this, there are many more things which we need to know about isothermal process. Like, this process should be carried out very slowly. Now what is the reason behind it? Why it should be carried out very slowly? Because as we know that during this process we need to keep the temperature constant. Now imagine any type of process occurs, like we have removed the weight, and while doing so the piston will move backwards and pressure will reduce. So in this process the temperature may lower, but we need to keep the temperature constant, so the heat must be supplied during this process. So
the process should be carried out very slowly, so that during each step the temperature remains constant. So you can easily correlate this process with the quasi-static process. It is just like a quasi-static process in which it should be carried out in a very small steps, and so it need to be undergo in a very slow manner. Now, example of this isothermal process in daily life is we design our air compressors uh, based on isothermal process, because isothermal process corresponds to the lowest amount of work. Apart from all the processes, isothermal process needs lowest amount of work input. So air compressors are usually designed with a very slow speed motors, so that during the air compression process, the heat generated during the compression work should be dissipated out of the compressor valves. So as more slow will be the process, more will be the efficiency of the compressor, and lesser amount of the work will be required to be transferred. So air compressor is a good example of isothermal process.
So let us draw this process on pressure and volume graph. Now let us say the system is at point 1 with coordinates P1 and V1. Temperature is equal to constant, and it undergoes a process like this and takes a new coordinates P2 and V2. So like this, here is V1, here is V2, here is P1, here is P2. So this is your process. Now let us calculate the work done, expressions for work done. Expression for work done in isothermal process. Constant temperature. Now as we remove the very small amount of work, this amount of you can say weight from the piston, so very small amount of work can be calculated by integrating the pressure and volume between 1 to 2 states. So work done is equal to P times V2 minus V1. Now here you know that P into V is equal to constant according to Boyle's law, and we can write as PV is equal to C, and we can write P is equal to C by V. Now I just replace the pressure value of pressure with C and V, so it becomes C by V, V2 minus V1. So we can also write in terms of log, natural log. If we integrate this here, so W between 1 and 2, let us say dW is equal to 1 to 2 P into dV. So this is equal to this. Hold on. Now we can replace the value of 1 to 2 C by V into dV. So this becomes C into log of V2 by V1 log E. Now we can also write it as C times, now PV is equal to, PV is also equal to MRT, taking mass is equal to 1, so PV or C is equal to RT. From here we can replace this RT log of E into V2 by V1. So we can write here as work done is equal to this in case of isothermal process. Now change in internal energy. So delta U, now you know the equation, Q is equal to W plus du. Now du is equal to mCv T2 minus T1, and we know that T2 T1 is equal to T2 is equal to constant. So change in internal energy, therefore change in internal energy in case of isothermal process is 0. Third is heat transfer. Now Q is equal to W, as dq is equal to 0. So whatever is the work done, that work done is equal to the amount of heat added or removed from the system. So heat added or removed from the system is equal to the work done on the system. So we know that this is not possible according to the thermodynamic principle, because heat is a low grade energy and work is a high grade energy. So this is a hypothetical statement only. So you cannot assume that all the heat can be converted into work as per this equation. This is only idealistic equation, and so this is your isothermal process.